Welcome and hello. This is a video tutorial using HEC HMS, and in this lesson, we'll be dealing with the depth area reduction analysis. We'll be setting up an analysis run, running the compute, and then viewing the results. The depth area reduction is the idea that the average precipitation intensity decreases as the area of the storm increases. Thus, the average precipitation intensity of a large storm is generally less than that of a smaller storm. What I have on the screen here is a very small and basic meteorologic model, a network with three subbasins as well as a junction. If I click over here in the Components tab of the Watershed Explorer, you can see I have my basin, a couple different subbasins, and a junction. I also have a meteorologic model that's set up. It's using frequency storm. In fact, two of the requirements to use this depth area reduction analysis is that the meteorologic model must be using the precipitation of frequency storm or hypothetical storm right here. I'm going to go ahead and use frequency storm though. All right. And it looks like I deleted my data I had prepared. It's all right. I'll type it back in. So for my frequency storm, I'm setting it up to be a storm duration of 1 day, peak intensity of 1 hour. The intensity position will be 1/3 of the way into the storm. And then the area reduction in this table down here is going to be user defined. I'll say the storm area is 10 square miles and that it's uniform for all subbasins. All right, so let me go ahead and type in some numbers here. All right, these are the depths right here in inches for 1 hour, which is the intensity duration, up to 1 day, which is the storm duration. The area reduction function starts at 1 and decreases down to a lower number as the area increases, which is defined by this area reduction function right here. So I went ahead and typed in some numbers from 10 square miles up to 400 square miles, and you see that that area reduction factor decreases down to 0.66. Here's the plot of that data. Let me go back to the frequency storm and assign that same area reduction function to all of the durations. Okay, that looks good. I'll click save. That's good to go. All right, now the focus of this exercise is actually creating a depth area reduction analysis. And to do that, we'll go up to Compute, Depth Area Analysis Manager. Right now, I already have one created, and that's fine. You just go ahead and click New, Depth Area 2, give it a name. This is the one step out of 3 within this depth area analysis process of setting up a new analysis. The second step is selecting a basin model. And then the third step here is setting up a MET model. Okay, so I already have those assigned. And these subbasins, by the way, I should probably mention are 10 square miles, 50 square miles, and 200 square miles, all receiving the same storm treatment. All right, now we're ready to run the simulation. So we need to select the simulation or the depth area reduction analysis. So you can do that from the compute toolbar. If you don't see this compute toolbar, go up to view, toolbars, and then compute. That's how to toggle it on and off. I just toggled it off, so that's how to toggle it back on. Yeah, so go ahead and make sure that your depth area reduction analysis is selected. Another way to make that selection is come over here to the compute tab, expand your depth area, select the specific analysis that you want to set up, and then that should select it right there. So here's analysis 1, here's analysis 2. It looks like I also need to specify the start and end date time. So I've already got that set up for this analysis. So let's just stick with depth area 1. It's going to be a 3-day simulation. Even though the storm is only 24 hours, I wanted to see the effects of the runoff as well. All of the subbasins, by the way, have just a transform method. There's no base flow, there's no losses. It's just us sort of keeping it as simple as possible to isolate the topic of the lesson, which is the depth area analysis. One last thing I need to point out is if you click on compute and then go to the depth area, besides the data shown here for basin model, meteorologic model, the start and end date time, we have this other tab right here for analysis points. This is the location where we need to specify the different elements within our basin that we want to perform the analysis on. I've selected all the elements in my basin, which is the 3 subbasins, as well as the junction. All right, so I think we're ready to run the compute. There's a few different ways to do that. from this Compute tab in the Watershed Explorer, you can just go right-click, Compute, and that is it. Another way to do it is just click this Compute button right up here in the Compute toolbar. And then a third way to run the compute is with the selected depth area reduction analysis that you want to run in this dropdown, then go up to the compute and then select compute depth area. And then that's the third way to do it. If you notice when I clicked on the compute toolbar, you can compute multiple. This is if you have multiple set up, you can select them and then click compute. All right, let's go ahead and take a look at the results. There's a summary table. It's the first result. Peak flow summary is right here. So go ahead and click on that from the results toolbar. Each hydrologic element or analysis point here has its own row in the table with columns for the analysis point name, drainage area, peak discharge, and then time to peak discharge. So this was a 1 hour time step. So this time to peak discharge is probably just going to be to the nearest hour, not necessarily as accurate as possible there. So we have the 10 square mile basin, 50 square mile basin, 200 square mile basin with the corresponding peak discharge in CFS shown in this third column here. And we also have this bottommost row in the table for junction, which also has its values for drainage area, which is the sum of the other three, and then peak discharge and time to peak. If we want to look at the individual element data, or the results, we can go ahead and click on one, like subbasin here. And let's see, hold on. I think I got to go up to results, select point, and then I'll say subbasin 10 square miles. Okay, cool. So now I can click on these buttons up here. So for just the subbasin that's 10 square miles, here is my results. Here's the hydrograph on top, the hydrograph on the bottom. Keep in mind there's no losses or base flow, so that's why it looks so simplified. There's no base flow element. We can also click on the summary table right here, as well as the time series table, which gives us the data that made up that graph we saw earlier right here. Okay. So we can do the same thing for all the different subbasins. You'd have to make sure to click on select point in 50. That's how to do that. Also, we can right click, view results. And just as before, we can view the graph, summary table, and time series table. So this should look familiar. Of course, it's the 50 square mile subbasin, so a little bit more flow. The third way to look at the data is to go ahead and select results. And then with subbasin 50 selected, for instance, we can also click on the graph, summary table, and time series data. All right, there's two more ways to see the results. A little overkill, but it's all good. Watershed Explorer, click on the results tab here. And say we want to look at the subbasin that's 200 square miles. Go ahead and expand the results from that table. And now we can see the graph, the summary table, and time series data by just clicking on these icons here. There's the graph, here's the summary table, and then here is the time series table. Okay. We also have some data down here that's saved to the DSS file. So let me go back to the Compute tab, click on that depth area analysis. Now down here in the Components editor, we have an output DSS file path that shows that the data that was computed from this depth area reduction analysis was saved to this depth area 1.dss file. So I'm going to fire up DSS view and let's take a look at that. Here is the project directory. And if I click on that, just inside I have depth area 1.dss. So if I open up that file, I see all the paths in that DSS file. Part B has the hydrologic element, such as junction, subbasin 10, 20, 250. And then part C represents the type of data. So for part C, if I wanted to just see the flow, for instance, I can see that for the different subbasins. I had to expand the column a little bit further right for part F so I could see the difference why each of these subbasins has two different flows for part C. One refers to the flow to the junction and the other is just to the subbasin itself. So if we wanted to like graph these, we could also look at the data. So let's just go with subbasin 10 square miles. Here is the plot. This should be the same hydrograph we saw when looking at the same data in HMS. And also I can open up the table data. So just as before, we can get the time series information on the hourly time step. We can also show all this data combined together. So if I hold down Control and then click on all of these flows, then if I click the plot here, we now see a combined hydrograph where the green is the total combined outflow for all three subbasins. And then let's see, yellow right here. This is going to be the 200 square mile subbasin. Blue is going to be the 50 square mile subbasin. And then red with its small contribution is the 10 square mile subbasin. All right. We can actually bring up a plot like this in HMS as well. It's a little bit cumbersome, but I'll show you how to do that. Go to the results tab here. And then what we want to do is expand each of these folders. So yeah, depth area analysis. And then, so for junction, open up the junction, and then here's the outflow. Okay, so then let's just expand all the others. So here is the 200 square mile basin. I'm going to hold down Control, click on outflow, scroll up to the 50 square mile basin, hold down Control, single left click on outflow, and same thing with the 10 square mile basin. So you can see the preview down here. It's the same plot that we saw. It doesn't give you a lot of tools or flexibility to modify this plot. But with everything still selected, you can come up here and click on this graph button. And now it pops up in its own window which gives us the ability to maybe change the colors. So I could go in here. Blue is fine. Let's just make it a little bit wider. And then I like the solid color. And then let's change it to something else, maybe purple. And then let's make that wider. And then the 50 square mile, how about green? Make it a solid line, make it a little thicker. And then the last data series here is 10 square miles. How about red? And then let's make it a solid line and also a little bit thicker and apply. Okay, so this is kind of how I like to do the plots. It's a little bit thicker, easier to see, and it's different colors than the default settings. All right, well, that was it on this lesson about how to create a depth area reduction analysis, how to run that analysis, and then the different ways to view the results.